Hi, great to have everybody here. Welcome to our super spreader event. it's it's so great to have everybody back in person. It's exciting. I put a little jack-o'-lantern full of candy outside my office, and it empties out every day. So I know that students are back, which is wonderful. It's just one, right? So we invite Allen School faculty who have joined the emeritus ranks to give a valedictory lecture, sort of a chance to reflect on their career in their field and their time in the Allen School. And today it's a huge honor and pleasure to be able to welcome Oren Etzioni, who's been a friend and colleague of mine for many years. Oren received his bachelor's degree from Harvard in 1986, his PhD from Carnegie Mellon in 1991, working with Tom Mitchell, and joined our faculty at that time. Along with Dan Weld and Steve Hanks, Oren really established the foundation that ultimately made the University of Washington a real power in artificial intelligence. He's done work in meta search, in online comparison shopping, machine reading, open information extraction. He's also an entrepreneur. He's done at least 5 companies I'm aware of: NetButt, Django, ClearForest, Faircast, and Decide. In 2014, he was asked by Paul Allen to become the founding CEO of the Allen Institute for Artificial Intelligence. And I think we, while not at all enthusiastic about losing Oren from the faculty, were enthusiastic about the prospect of AI too. The notion was that if Paul and his organization could do in artificial intelligence for Seattle what it had done in brain science, it would be a gigantic win for us and for the region. And it has been more than that. It's been phenomenal. Again, it wasn't obvious Paul was going to do an AI institute. If he did, it wasn't obvious it would be in Seattle. And if it was in Seattle, it wasn't obvious that a faculty member who really cared about the Allen School would be selected to lead it. And all of those things came to pass. And Oren has built AI2 into a powerhouse with lots of involvement from our students and our faculty, this mission of AI for the public good. And it's been just a gigantic win. Oren retained his Allen School faculty appointment until 2020, when our leave policy timed out and he went emeritus. At the end of September, he stepped down as the CEO of AI2. His involvement now is as a board member and technical director of the AI2 incubator, and we look forward to much more involvement in the Allen School by Oren going forward. And in particular, he's going to help me and Greg Gottesman teach our entrepreneurship course winter quarter, which I'm very excited about. Today, Oren will speak about what I learned, stories and lessons from an academic lifetime. I give you Oren Etzioni. Oren, thanks for being here.
Ed, thank you for the kind introduction, also for lending me your clicker. Ed is actually a huge hero of mine for many reasons. He's been very supportive of AI2, but really his selfless devotion to computer science and engineering in this department and this school. In fact, the fact that you're sitting in this wonderful auditorium and building is very much a testament to Ed. So, but enough about him. Let's talk about me. There's actually a few talks that I could give because I've had the fortune of being a venture capitalist at Madrona Venture Group, starting companies, working with the AI2 incubator, being the CEO of a research organization. But I'm going to focus on my academic work. And I know most of you are not professors or planning to be professors. That's all good. This talk hopefully will have broadly applicable lessons. And regardless of that, I aim to make it amusing, entertaining, at least as entertaining as Paul Beam's last talk on lower bound complexity of arithmetic circuit verification. So with that, oh, you were at that talk. Excellent. Hi, Paul. With that, let's see if I can get started. Yeah, technical difficulties. You know, I haven't been in person, right? Not sitting at a Zoom screen for a long time. Ed?
Well, we're about out of time.
Okay. Thank you. It would have been a short talk. So let's go back to 1990. This is before I ever been to UW, ever been to Seattle. I was invited for an interview in Cornell and went over there. And one of my very first meetings was with John Hopcroft, Turing Award winner, writer of some of the most emblematic and formative textbooks in the field. How many people have studied from one of his textbooks? Okay. I guess there are newer versions. Anyway, this is his picture. He sports what you might call Voldemort chic. This is actually an older, this is a recent picture of him. Remarkably, 30 years ago, he looked the same. So,
say that he grew up in Seattle and was an undergraduate at Seattle U. And at one point, a number of years ago, I met his high school girlfriend, which was a real experience.
That's great, but Ed, what makes you think that this is a participatory interactive film? Settle down, settle down. I wanted to be a comic, and you can see I've practiced I can handle hecklers. So, I was in his office after Ed met his girlfriend, whatever. I was in his office, and he says to me, "You want to hear the secret to academic success?" I say, "Absolutely, please." I'm this young, eager student. He says, "Just say no." I said, "Okay." He says, "You get so many invitations, so many opportunities, so many distractions. You have to be able to say no." And I actually have a note taped to my phone. I mean, this is so long ago that people actually had phone calls. This was like a phone. It wasn't even cordless. It was that long ago. And taped the phone and it says, "Just say no." And while we're there, the phone rings. This is a true story. And he said, "Do you mind if I answer that?" I said, "Of course not." So he picks up the phone. He goes, "Hello." He goes, "No." He goes, "No." "No." He hangs up. I say to myself, here's a man who practices what he preaches. And ever since then. So why is it actually hard to say no? Look, we all want to be liked. And I always try to remember that I want people to like me for who I am, not for what I do for them. Also, often there's a sense of urgency. You get an email with a request and you feel like, I got to reply. Or even worse, somebody calls you, stop by your office. Hi, Raj. You feel like you need to answer them right away. And what I advise is take time to consider, maybe even bounce this off a skeptic. I have a couple of colleagues who regularly, when they're invited to do something, forward it to me and say, "Oren, should I do this? What do you think?" Not because they're delegating the decision to me, but because they know that I will present the skeptical case. Do you really need to do this? You'll need to be on that study group for DARPA, IARPA, MARPA, whatever. Maybe, but it just gives you some time to consider it, get another perspective. One of the hardest things for academics, one of the hardest ways to say no is because often these invitations are prestigious. Could you be the chair of this conference, very prestigious, editor of this journal that nobody reads, but it's very prestigious. Could you be the sub-area chair, subcommittee, member of the academy, blah, blah, blah. Paul Graham, who's a venture capitalist and an essayist that I admire a lot, said prestige is especially dangerous to the ambitious. He points out, if it didn't suck, they wouldn't have had to make it prestigious. So really, prestige is bait. Don't fall for it. My advice to you. And by the way, I did receive a faculty offer from Cornell. It was quite prestigious. I said no. Okay, so that's the no part of the talk. What do you say yes to? Well, there's plenty to say yes to. Genuine service, right? If we write papers, we ought to be reviewing papers. And actually, the ratio is there are multiple reviewers per paper. So I tried to review at least 3 times as many papers as I authored. Helping a friend. There are so many situations when you can help a friend review their talk, their paper, what have you. Definitely a thing to do. There are also learning opportunities. This picture is meant to convey that sometimes you can climb a short distance and see a grand vista. You can do a little bit of work and learn a tremendous amount, and that's another easy yes. But the biggest easy yes is a project that you're passionate about. So one of my favorite sayings, which I etched on the walls of AI2 Oh, Peter Clark is here, who's now interim CEO. Sorry, Peter. It says, life is too short to work on a project you're not incredibly excited about. Okay, so that gives you some constraints, but it still doesn't tell you what to really work on. So I started casting about for heuristics, and I asked my old friend Albert. Well, I didn't meet him, but I met his girlfriend. No, and he said, I have a little patience with scientists who take a board of wood, look for its thinnest part, and drill a great number of holes where drilling is easy.
Machine learning.
And you know who you are. Don't do it. Don't write that incremental shit. But it's still pretty non-specific. So I thought of Noam Elkies. He's truly a friend of mine. Yeah, I went to elementary school with Noam Elkies. I remember in 4th grade being forced to listen to original piano compositions performed by him. He was in 3rd grade. It was just a nightmare. At age 15, he won the World Olympiad with a perfect score, the World Math Olympiad. At age 26, he became the youngest tenure professor at Harvard. I like to refer to him as the smartest person possible. So I figured, okay, how does Noam choose research problems? I've learned from him. So actually, we met near the hub. He was in Seattle. And I said to him, Noam, how do you choose your research problems? He said, it's very simple. I look for a problem that hasn't been solved for 50 years, 100 years, and I solve it. And that seems to work pretty well, getting a lot of good results. I said, okay, that works for Noam, perhaps not for me. I asked Herb Simon, Nobel laureate in economics, Turing Award winner, many other accolades. He was a towering figure when I was in grad school at Carnegie Mellon. And he said, of course, pick an important problem, not one of these thin wood ones. But he said, pick one where you have a secret weapon. So what exactly is a secret weapon? His favorite example was Antony van Leeuwenhoek, who built the first microscope in 1676. This is roughly what it looked like. And he and his students were the first to observe muscle fibers, bacteria, red blood cells. Basically, everything they looked at through the microscope was immediately a result that they could publish. What a great secret weapon. He had a microscope. Other people didn't. You're golden, right? So if you get a microscope, you're in great shape. And there are modern versions thereof. So a tool is a great example of a secret weapon in science. But there are many other ones. Another one's a data set, right? If you have a proprietary, unique data set. Fei-Fei Li at Stanford worked for 7 years to create ImageNet. And there was a tremendous amount of research done on that initially by her. Background knowledge. What if you come from one field, I don't know, neuroscience, Raj, and you move into another field, right? You can bring those ideas and help design the field, right? You could be a computer theoretician and get into mechanism design and help game theory. These are little inside jokes for some of my friends in the faculty who showed up. But you get the idea. Your unique knowledge, or relatively unique knowledge, can help you when you move across fields or subfields. Another great one that's really accessible to anyone is you can define a new problem. If you define a new problem, you have the chance to be the first person to think about it, to work on it. It better be a good problem, otherwise nobody cares. Another example is you can bring a new perspective on an old problem. And a phenomenal example of that is the work of Yejin Choi, who just won the MacArthur Genius Grant. She's been working on the problem of how do you endow computers with common sense. But she's used modern approach based on crowdsourcing, deep learning, methods like that. And that has allowed her and her team, hi Ronan, good to see you, to really make some terrific headway on this problem. So these are all terrific examples. This new perspective on an old problem is one of my personal favorites. So if you'll bear with me, I'll just give you a couple of examples. One is from the problem of clustering. So to those of you who don't know, clustering is, my 12-year-old son is here. So this is for him. Michael, are you writing this down? So you have unlabeled data represented as points in vector space, and you map it into groups. This is an example of k-means, a famous clustering algorithm. But there are lots of algorithms to do this. They all represent the items to be clusters as points in vector space and compute distances over them. I was interested in the problem of clustering documents. This had to do with web search. We're about to get into that. And documents are actually sequences of sentences, and sentences are sequences of words. So I asked the question, can we use the fact that these are sequences, not just points in vector space, to build clustering algorithms? And the answer was yes. It turned out that we were able to come up with a whole class of new clustering algorithms. They were linear time. They were highly effective, more effective than the standard. This was in collaboration with Dick Karp, who was here at the time and became the PhD thesis of Oren Zamir, who promised me he'd be watching this over the internet. Hi, Oren. Nice work. Another example is the problem of information extraction. Information extraction is mapping sentences and text to a more structured representation, like a database or a table. So we have the sentence, and we can see, for example, that what the conditions are, what the symptoms are, the age of the patient is 72, et cetera. This is typically done as an example of what's called supervised learning, right? So you take your target concept, like age of the patient, you have examples, training examples that are labeled, yes, no, et cetera, and you automatically build a model. The problem with this approach is that it's actually not very scalable if you try to scale it to the web, right? So in the web, we have billions of sentences, we have millions of concepts, and we're short on labels. So you can't actually apply information extraction to the entire web. And so we had the idea of building what we called open information extraction, which is an unsupervised technique where you can actually automatically, using regularities in language, figure out how to extract information from sentences. And our motto was no sentence left behind. We could extract some high quality information from virtually any sentence. This was the PhD thesis of Michel Banco, Mike Caffarella, Doug Downey got involved, the late Stephen Soderlund. Dan Weld was a huge influence and contributor to this work. Massam was here on the faculty. Michael Schmitz was undergrad here. One cool thing about this list is roughly half these people are at AI2, and the other ones are collaborators of AI2, with the exception of Michel Banco, who escaped to the Bay Area for reasons unknown. But that's another story. This work received the Test of Time Award just earlier this year. And if you squint enough and kind of contort your body, you can claim it's a precursor to some of the work on generative language models, which is the hottest thing going. Let me be clear. That statement is not actually true, but you could try and claim that if you were. Okay, I digress. So in the 90s, this is my last example, I launched the SoftBot project. The SoftBots project was the idea of replacing the direct manipulation paradigm that we still all use, right? Mouse and windows and icons and clicking and all that with an intelligent assistant. That's actually an old idea, but we had a new perspective where we would have the user say what they want to achieve, and the SoftBot, the software robot, would figure out how using reasoning about action, intelligent planning. And again, this was a great contribution of Dan Weld, who's here. Dan is known as the father of modern planning, a very august title that was given to him. It was given to him by me, but it's true. So we did a lot of good planning research in the context. Another secret weapon, and this is by Rich Siegel, who was my first grad student, was we realized that while people building robotic agents have to worry a tremendous amount, even today, 30 years later, about the grippers and sensors and the robot breaking down and continuous sensing and environment and motion, just a huge set of obstacles. If you wanted to build a software agent, these sensors and the effectors are just strings you can send back and forth to the Unix shell. So when Rich Siegel in a week built this simple manipulation of the string buffer, I realized that we had something very cool and unique. And for years we did, I think, very interesting research in SoftBots. So while we were doing that, I had a student named Eric Selberg. Eric came to me and said, hey, what if we built a simple softbot to search the web? Now you might say, what's the point? We have Google, right? Who needs to build that? But this is 4 years before Google. Anybody here remember a world before Google? Okay, a few. I'm impressed. You have good memories. Anyway, I barely do. This is 1994. Now, Eric, again, I could give a whole talk about Eric. He's a zany character. He would get into fights with people about furniture. Actually, great guy. But I wasn't always inclined to just agree with his research interests. I said, what's the point, right? There's these search engines. Search was not as big back then. What's really the point of doing this? And he explained that the different search engines actually only covered small fractions of the web. They were inconsistent in their syntax and the results. Something as simple as doing a search for a phrase would be very different depending on what engine you used. So we went back and forth on this. Finally, Eric said, look, it's just going to take me a month to build this thing. Give me a break. And I thought to myself, another key principle that I like to invoke is an ounce of data is worth a pound of my intuition. So my intuition was, this thing is going to suck. But hey, I'll give him a month. So a mere 2 to 3 months later, always takes a little bit longer, Eric built the web's first meta search engine. Meta search, the idea is that instead of indexing pages on the web, you take your query, you send it the way a softbot does to different search engines. You collect the results, you normalize them in various ways, you rank them, and you produce a comprehensive report of what the different search engines were saying. And this was called Metacrawler. And that's, again, a reference to a project that was called the Web Crawler that was done here by Adam Pinkerton. There's a rich history in search, and Ed will fill you in on whose girlfriend was involved later. So some of the secret weapons here were Eric's hacking skills. Actually required some work to build this and make this work well. The idea of softbots and applying them to search. And it turned out also the CSE community, because when Eric built a prototype, he released it locally, and we started getting really good feedback from people just like you, except 30 years older. One of the non-secret weapons that we had is user interface design. So this is what the front page looked like back at the time. It was amateur hour, but it was actually a pretty useful tool. We were pretty excited. Then Forbes magazine somehow got wind of this. And Forbes magazine at the time was actually quite a renowned journal. Popular magazine. It was before there were a lot of other ones, and they've gone downhill. At the time, it was a big deal to be the cover story in Forbes. And they interviewed us, and I was really excited. Okay, this is going to come out. People are going to see our work, not just people in CSE. And you have to imagine back then, things didn't appear online only. They didn't appear online first. There was actually no online for Forbes magazine. It was a physical paper thing. And so I started going every day to Bulldog News on the Ave. I think it's still there, waiting for this to come out. I was just so excited. And every day I would go, and they got to know me. They're like, no, it didn't come out. Finally, the first day this thing came out, I get there early in the morning. I get my greedy little hands on this. I flip open, and we made it to the big leagues. There was an article that said good things about us, about other things, but there was a table there of the 7 top search engines. I don't know if you can read. There was something called Lycos. There was Yahoo. Again, there was no Google. It was before Google. But there was Metacrawler. We were there. This was huge. There was only one slight problem. They got the URL wrong. I'm serious. So I'm looking at this, and we're in the big time, and then I realized nobody, if you went to Metacrawler.com, you'd get a 404 error or whatever, right? There was no Metacrawler.com. So I was like, okay, what do I do? Do I request a correction that will then appear like a month later in some small errata? That's meaningless. I want to get Metacrawler.com to point at our implementation. But this is actually breaking new ground because, as you know, we're a public university. There's the state ethics law, which I've been told about for 30 years. I've never actually seen it, but I'm assured it exists. And would this be violation of the state ethics law to take a .com address and point it to an edu site? I said, well, I could ask the UW Attorney General, and a few weeks later, I might get an answer. They usually hem and haw, so I won't. And again, this is going to be a disaster. So instead, we decided to just do it. Now, just to be clear, in case this is not okay in any reason, Eric is the one who did it. Eric. But I was involved in a non-legally binding way. So we did it. And then we started watching the traffic, and it started doubling. It was actually really exciting. And it's not just that it was doubling, it was the diversity. People are coming in from Intel, from the World Bank, from all over the world. And they were clearly, it went viral. They were sharing it. So we were experiencing exponential user growth. Really, really exciting in 1995. In 1996, Eric Lundberg, anybody here remember Eric Lundberg? Okay. So he comes to me, really nice guy, and he has this pained expression on his face. And he says, Oren, and I'm like, Eric, are you not feeling well? He says, Oren, we have to shut down Metacrawler. I'm like, what are you talking about? This is my baby. It's growing. It's exciting. He says, look, people can't access their homework on the file system because it's taking up so much bandwidth. You have to get this thing out of the university. It was doing all kinds of processing to create this uniform report. The details don't matter. So again, I could give a whole nother talk about what happened to spin this out, but long story short, it was spun out and ended up in a small public company in Seattle called GoToNet. It scaled up to millions of queries per day, which was extremely exciting. Back in 1999, Larry Page asked for Google to be included in Metacrawler. I was like, ha! I felt like George Costanza in the Seinfeld episode where he breaks up with that woman. If you're a Seinfeld fan, you know what I mean. I had hand. If you don't know Seinfeld, you have no idea what I'm talking about. This also resulted in substantial revenue for GoToNet. It was pretty exciting. Of course, ultimately it led to oblivion because Google took over, but that's another story. So in 1998, in no small measure based on this, I was invited to be the CTO of GoToNet. And I said, yes, I'll do it. I said, right after.
Was it prestigious or no?
No, it was not prestigious, but it was exciting. I was very passionate about Metacrawler. Thanks for checking. There will be a quiz after the talk. I'll be handing it out. Luis is always, Luis, you can stay and erase the boards after class. So, but I was committed to UW. This is 98, and stay with me in the details here, because the details, the dates and the numbers are really important. So I said, sure, I'll do it. But after I finished teaching CSE 574, Advanced Graduate Seminar, in March. And then a really strange things happened. The folks from GoToNet just didn't answer me. So, I emailed them again, I called. No reply. In retrospect, I think I should have just gone to their office and parked there. But I didn't know. I was like, why are they not replying to me? But they really weren't. And suddenly in March, okay, while I'm teaching 574, it was announced that Paul Allen is investing $300 million in GoToNet. The stock shot up tremendously. And it was a very exciting moment for the company. And in April, I joined as CTO. Now here's the problem. Again, the way these things work is your compensation is largely based on stock options, and stock options are priced the day you joined. And so when I joined in April, the price of the stock was very, very high. Had I joined 2 weeks earlier, it would have been a lot lower, and I would have made a killing. In fact, I won't get into all of the numbers here, but let's suffice it to say that I could have canceled 574, paid each potential student $50,000 as compensation, and still made a killing. But I didn't. because of my commitment to this institution. Yeah. Yeah. You're clapping. I regret this. This was a dumb move. I put this in just to tell you that, like, all these stories, Oren thinks he's so great. Believe me, I've made my share of mistakes, and this is just one of them. But it did teach me to be alert to opportunities. So fast forward to 2005, a gentleman named Jonathan Poole emails me just out of the blue, some random email address, say, I'd like to fund some NLP research on low resource languages. So I go through my list. Okay, is this Paul Allen? No. Bill Gates? No. DARPA? No. But my job, right, as a professor, is to look for funding for my students, for my team. I like to say that I eat what I kill, right? That's what professors do. In fact, my favorite description of the university is a bunch of small entrepreneurs joined together by a common grievance about parking. So I was done complaining about parking, and I wrote back and I said, NLP research are us. Come on down. Everyday low pricing. And we had a series of conversations. It was really a wonderful, wonderful man, and very, very deep in his thinking, and also his pockets. And it ended up being a multi-million-dollar gift to fund the Turing Center at CSE, which was a wonderful thing. After all this was said and done, I asked him, we were having dinner, and I said to him, Jonathan, why did you choose me? Because the truth is, well, I've been working in NLP some, low resource languages and machine translation, that was part of it, as Noah knows very well. That is not my thing. Why did you choose me? And he said, well, I sent more than 15 emails to people in the field of NLP. You're the only one who replied. There's a lesson there. Now, I'm not saying listen to the scammers, right? I mean, there's plenty of scams, but this was a bona fide guy, and I could tell from a Google search, it was worth responding to his email. Well, it worked out for me. So then fast forward to 2013, and what was for me the mother of all opportunities, I got an invitation to launch this new AI Institute for Paul Allen. And as Ed said, I was very much encouraged by him and by Hank Levy to go. They were like, go, go, go. Yeah. It reminds me, my mom said to me one time, this is when I was a little kid, she said, Oren, if a car stops by, you're in the playground, a car stops by and a stranger offers you candy or chocolate, she said, go. No. Both are not true. Ed and Hank were very encouraging, but they said, yeah, you could stay, I guess. So I asked a lot of questions. What would success look like? What's the timeline on this? What resource will be available? How will this be endowed? Can we do this actually inside the University of Washington? The answer to that last one was no. Paul had already said, look, I'm already funding a university department. I want to do something very different. But the response to all the other questions were, figure it out. So I said, okay. I joined Vulcan, which is his holding company, and I interpret this as the sky's the limit. And Peter Clark, who's here, loves to tell the history of AI too, and I joined, and I said, okay, we're going to think about this, develop a plan, talk to people. I got there, they were like, okay, you have 10 days to figure this out. So I said, great, how much can you do in 10 days? So I created a presentation. This was the first slide. As you can see, I didn't take it all too seriously. I'm thanking Peter, some other folks. Alan there is the head of the Allen Institute of Brain Science, who's a big mentor to me, and made this proposal. Okay, here's how we would build AI2. And there are a lot of details that are not interesting, but there was one key question in my mind, and people asked me that over and over again, although they didn't use this terminology, right? They were talking about your competitive edge. They were talking about how are you going to recruit people. Basically, they were asking, what's going to be your secret weapon? And it was clear in my mind from day one that this was the answer, that the Allen School, that computer science was going to be my secret weapon. And that meant that we would build a collegial culture that would be welcoming to CSE students, to CSE faculty, that we would remove IP barriers, right? You wouldn't have to worry about if you write code here, can you transfer it there? What about the data? We're a nonprofit, we're not going to worry about that. We would allow joint appointments across the institutions. We would provide research funding so that folks could spend less time chasing DARPA grants and more time available to them at AI2. We would provide flexible internships. It's not, hey, you can just come during the summer. You want to come part-time just on Tuesdays and Thursdays? Sure. You want to come in the spring quarter? Sure. Anything to make AI2 welcoming to UW, because I knew the talent that was here, well, at least was here years ago. No. And then I said, that's all fine, but this is, before COVID and things were very geographic. I said, I've got to have this place be really close to UW so that it's convenient. So people like Noah Smith can bike to AI2 on their way to UW from his home in Wallingford or wherever it is he lives. And Wallingford? Yeah, thanks. And I like to get my facts straight. So here was a problem. It turned out that Vulcan Real Estate, which is a major multi-billion-dollar corporation that was part of Paul Allen's empire, they had other ideas. And they made billions of dollars for him. They're a very strong organization. They said, why don't you put Etzioni and his merry gang of whatever AI people in this hole or in Sodo or in, look, we've got an open space, it was just a cleared out homeless encampment. They could move in there. Yeah, there's no restaurants. There's no way to get there. Doesn't matter. And then the finance people got involved. And they were like, hey, look, being next to UW is going to be a lot more expensive. Long story short, everybody in the Vulcan organization who could spell Orin or could spell AI lined up and said, we can't do this AI2 thing. And I had this wonderful space right by Gasworks in mind, right on the Burke-Gelman Trail to here. And so they were saying no. And I refused to back down. I thought this is really essential. And so it ultimately escalated to Paul. And the way these things work, I didn't get to talk to him about it. A bunch of emails were exchanged. And then the decision was handed down. And the AI2 offices are right here, this beautiful shot by Peter Clark, right off the Burke-Gelman Trail. So you can bike from here to UW in just 5 minutes. You can walk in 10 minutes or so. And that made a huge difference for the relationship with the Allen School. It was also a place where we could talk to people about our vision. This is actually the picture from our deck at sunrise. And that was a huge moment for AI2 because Paul Allen said, I don't care about the costs within reason. I care about building a world-class institution. And that was very meaningful to me and to the people at AI2, and it was a key fork in the road for us. So fast forward over the years, a number of AI2 faculty members have joined the leadership of AI2. Several of them are here. Ed joined our board of directors, and he's been an incredibly dedicated champion and director of AI2, and I think now is the time to reveal the behind-the-scenes figure of how much Ed, on the side gets for this kind of thing. Zero. Zero compensation. Hey, talk to Peter. But these folks are the amazing people that have really helped to build a place. In addition to interns, postdocs, members of our team that we've hired, more than 40 of them come from UW, founders in the AI2 incubator. A lot of companies are from UW alums, and so on and so on. And I won't talk a lot about AI2. Again, it's a whole nother talk, but I did want to share with you a few numbers just so you get a sense. There's over 200 team members at AI2 in that space I showed you. We've, over the years, garnered 29 award papers in a variety of conferences, from NeurIPS to AAAI, some of the very best conferences. Our annual funding is roughly $100 million in research funding, which is a very substantial amount. Semantic Scholar, our free search engine for academic research, which Dan Weld, who's here, heads, has had more than 100 million users. And the incubator itself, if you add up the value of companies that were sold, like Elise Exnor that was sold to Apple for, oh, I can't say, and the different funding rounds and so on, it's a very sizable figure. So we're quite proud of this numbers. But more than anything, I'm really proud of the culture of AI2, and I'll have something more to say about that in a second. So now, as a good professor, let me give you a recap of today's lecture, and yes, everything here will be on the midterm. Just say no. Prestige is bait. Life is too short. Remember that. Life is too short to work on a project you're not incredibly excited about. Life is too short to work with people you don't enjoy working with. Life is too short for many things. Keep that in mind. Have a secret weapon. This isn't just for academia. Whenever you enter a project, you have to ask yourself, what's going to be our competitive edge? An ounce of data is worth a pound of intuition. It's worth a pound of my intuition. I dare say it's worth a pound of your intuition. I'm very much an empiricist. That's how I was trained at CMU. Be open to opportunities, okay? Not the one that's addressed to whom it may concern, okay? Not those, but there are opportunities, and it pays to be open and timely in responding. Some chutzpah is required. There are times where you have to stand your ground, and I'm very pleased that I did. And if it's not clear from all the pictures and comments and so on, so much is about people and culture. I was a hacker, computer science major, wrote all these papers, and I thought, it's about the machine. It's not. So much is about people and culture. And I have to say that in my experience, it does not get better than the Allen School and AI2. The culture in both these places is so special, so collegial, and wonderful. And actually, I'm going to end with Ed's words that are so articulate. I'm just going to read them almost verbatim. And he said, Oren took the collegial and collaborative culture that he absorbed in 20 plus years as a professor in UW's Allen School and mixed it with a singular focus to create an elixir that AI2 folks have been drinking over the last 8 years. The result is an exceptional organization of scientists, engineers, entrepreneurs that's pursuing Paul Allen's vision of AI for the common good with extraordinary success. Thank you, Ed. Thank you. A heartfelt thank you to my students, my colleagues, and friends. And that's the story. Thank you very much. I'll take questions. I see Ed preparing to get up. Relax, I got this. I'm a trained professional. If you have questions, comments, very welcome. Magda.
So what's next?
A lot of people have been asking me that question. And what I say to them is, I'm used to the academic cycle where every 7 years you have a sabbatical. So my sabbatical is 2 years overdue. What's next is I'm taking a sabbatical. I'm definitely excited to re-engage with the Allen School to teach the course with Ed and Greg on entrepreneurship. You're all welcome. I'm competing in the Bug House World Championship with actually an Iran-American team that I'm actually quite pessimistic about, but that's another story. And I'm taking a deep breath. After that, the sky's the limit, but I'm not sure that I want to manage a large group of people. Again, it's a lot, as you know very well. So so we'll see. But you can bet one thing, that whatever I do next, I'm going to be incredibly excited about. Yeah.
Can you talk a little bit about the vision of AI for the common good and what that means for the kind of projects and stuff?
Repeat the question, please.
The question is, could I talk about the vision for AI for the common good and what it means for the different projects? No. No, just kidding, just kidding. So I think it has two components, very sincerely. One component is there's a great line that characterizes AI2 that's due to Noah Smith, which is AI2 does the work that universities can't do because they require more resources, engineering, compute, et cetera, and that companies won't. So for example, the Semantic Scholar project that I mentioned uses AI to make search, academic search and discovery much easier than ever before. We're actually launching now, under Dan's readership, another project called the Semantic Reader Project, where we're trying to make reading papers easier, right? The history of reading papers for me is like, okay, I used to write stuff on the cave walls, then there was the Gutenberg press, then there was PDFs, and that's it. Right? Not a lot of advances. Well, this new reader makes it a lot easier to chase down references, to see summaries of sections, to skim, do a lot of support for a lot of the activities that we do in research. So this project, to make scientists more efficient at their job using AI, there's no money in it. Right? It's free and it's going to remain free. And that's an example of AI for the common good. Another example is the incubator that's created more than 500 jobs so far in Seattle in a short amount of time. We don't use personally identifying information, facial recognition, targeted advertising. That's not for us. I'm not saying that those things are bad, but we've chosen to focus on other things. We do a lot of work using AI in medicine to help fight diseases and so on. So those are also examples of AI for the common good. The third example, which would be more controversial to some people, though I'm not sure here, is basic research in AI. So we've done a lot of work on very fundamental research with the idea that if we can advance AI, we can use AI to help tame some of humanity's thorniest problems. And of course, it's up to us to make that come true. So that gives you a sense of AI2. Some applied projects like Semantic Scholar, which is our largest flagship project, and the incubator, as well as basic research. Did I answer your question?
Thank you.
There was another?
Oh, I was going to ask, so as Ed's quote points out, you're the one who's been creating this elixir. And when someone's been really instrumental in creating a culture in an institution, a transition can be difficult. So is there anything you did to prepare for that or try to institutionalize some of the culture?
Wow, what a great question. So, thanks, Ed. The question was, when you are create a culture and then you leave, how does the culture remain? What do you do to institutionalize that culture? And it's something that I've thought a lot about. And frankly, I think the jury is still out on that, because I think that we did a number of things to support the culture. Let me give you a very concrete example. Another saying that I didn't have a chance to include is Steve Jobs saying that a home run is worth a lot more than 2 doubles. So we really want to focus on breakthrough projects. Another thing that's really important to us, as I mentioned a few times, is a collegial culture. We don't want to have people jockeying for credit. Okay, who's the first author? Who's the second author? So when scientists at AI2 are reviewed, we ask them to put forward a single paper that they were an author on. They don't have to be the first author. They can't put 3 mediocre papers and say, look, none of these were that great, but I wrote 3, or in some cases 20, right? So give me one paper that's the one you're excited about, that's the one that matters. So that's built into our review system, and the goal is to get people to think about what's my most important work, and to not worry about, right, 6 people, 8 people can put the same paper forward if they contributed to it, right? So that's an example of how we institutionalize it. But it's really up to the people, okay? So all these tactics that I've employed in various ways to try and create a culture, and I could give you 15 more. I don't want to bore people, but really done a lot of little things. All those ultimately depend on the people and what they want to do. And I think it remains to be seen how things will play out. I think in the short term, Peter's at the helm. Peter is actually one of the people who recruited me to work for Paul. He's been at AI2 from the get-go. I think he embodies AI2's culture. So I'm not worried about it in the short term. But then there's going to be a new CEO, and time will pass. The Paul Allen's estate is meant to set up a whole structure where AI2 will stick around as far as I know in perpetuity. So what's going to happen in 10 years? That really depends, and I don't delude myself that I have a whole lot of influence over that. So it's a great question, and really a thoughtful one. It's hard to maintain culture, and I think CSE, if I dare say so, has the same issues, right? It's growing, it's vibrant, it's changing, and Ed and Hank aren't going to be around here forever. So how is CSE going to maintain its culture? Magda? Send me a report on this. Oh, I'm not the CEO. Never mind. Other questions? Yes, please.
AI systems are getting deployed in real world applications these days, and people are getting concerned about harms AI is going to do too. So what do you think AI2's role in that trend?
So the question is, as AI2 gets applied in real-world applications, people are concerned about the harm that AI can cause. And I didn't quite catch the last part. What do I think about that, or how do we fight against that?
Yeah, what AI2 specifically can do about it.
So I do think that AI is very much a tool. And so it's really up to the people to decide how they're going to use it. There's an interesting debate about the extent to which technology is inherently biased in certain ways. Does it concentrate power for certain reasons? Does it tend to amplify certain biases? I actually think that often it's the case that, for example, in the case of bias, that the data we put in is biased. The machine learns a model that can amplify that bias and then result in biased decisions. But there's, of course, a lot we can do about that, right? We can augment the data. We can change the optimization function. There's a lot of technical things we can do to counteract that. I think the short answer to your question is it really depends on the people who use it. And I don't necessarily think that it's a simple, oh, yeah, it's great. The people who use it do good. It's going to be good. It's going to be so good. Yeah, like the Russian military using, Iranian drones with computer vision capabilities. This is going to be great. No, I mean, there's AI-based weapon systems that are potentially very scary. There's been uses of AI documented that have been very negative, in the criminal justice system, et cetera, et cetera. But the solution that I see is to discuss it and engage in constructive uses of AI. I don't see another solution.
Just a quick question. Early on, you said that it can pay off a lot. You climb a short amount, you can see a huge vista. I was wondering if you have any advice on how to sense or find out those opportunities.
Yes, actually I do. So the question is around this idea that if you climb a short distance, you could see a huge vista. Sounds good. Cost low, benefit high. Who's for it? Raise your hand, right? The problem is detecting that. So I think that the first thing is to do a rational analysis. So often when we get into something, and we're passionate about it, we're curious, right? Universities for curiosity-driven research. We don't actually think, wait a minute, how much work is going to take to do this? Is this a week worth of work? Is this a month of Eric's time? Or is this going to take years to get to where I think it should get? So you have to be rational about the cost. And then when you see the cost, you can analyze and say, you know what, look, to do what I really want is going to take a year. But to do the first experiment that's going to give me an inkling of what's going on, I could do a rough prototype in a week, or I could, I don't have to build a large language model myself. Maybe I can just use GPT-3 and get some intuitions, right? So there are ways that we can optimize. These are basically lean startup ideas, ways that we can optimize the amount of effort we put in per learning. That's point number one. Point number two, to me, learning comes from surprise. Right? And surprise comes from data. Newell and Simon, when they won the Turing Award, the title of their talk was Computer Science as an Empirical Inquiry. I always think of it as the way that you learn. Sure, you can learn from professor, you can learn by thinking and so on, but you really learn from the data. And so a lot of the discoveries that me and my team have made have come from getting surprising data points. So another question you can ask yourself is, okay, can I generate data here? And what will that tell me? And more often than not, the data was surprising. And while I'm on this topic, let me just get a little bit geek here. Often when we look at data, we look at summaries of the data, right? We have happy graphs, right? Okay, on the x-axis, I've got whatever variable, and on the y-axis, I've got the performance measure that's going to get my paper accepted. And that's over 1 million data points. And often what people don't do is look at individual data points and individual examples to get the underlying intuitions. And so I'm a great believer in looking at the data, not at summaries of the data, and getting intuition from examples. I have to tell you one story along those lines. So that's the answer to your question. Get data early, get data cheaply, prepare to be surprised. Apropos examples, there's a very famous guy in AI named David McAllister. Very, very, very smart guy. You meet him and you're just like, holy shit, this guy's just breathes smart. And he says the kind of, he's also very macho, and he's got this like unblinking gaze. He looks at you and you're trying to talk to him about a technical topic. He says, don't give me examples. Examples confuse me. Just give me theorems. Like, okay. I got a little bit older, and I met him, you know, it was at one of these showdowns. I came into a blind alley in some saloon, and I said to him, David, don't give me theorems. Theorems confuse me. Just give me examples. It was a great moment. But I'm an empiricist, yes?
So what are your thoughts on the current state of AI?
So what are my thoughts on the current state of AI? Right now, AI is completely obsessed with what's called generative models, right? Foundation models where you take a large number of training examples, sentences or images, put them together in an unsupervised fashion into a model that's not just able to classify things like we used to, but actually able to generate new objects, new documents, new pictures, what have you. And the world is divided into two camps. One is 99.9% of the people are saying, wow, this is amazing, this is great, this is bigger than crypto, this is bigger than mobile, this is bigger than infinity. Sorry, Paul. And there's a really small group of people that I just referred to recently on Twitter as the party poopers who say, generative models, let's see you generate some revenue. How obnoxious. Anyway, so I think people are fascinated with the capabilities of generative models, both in research and applications, and that is the state of AI in 25 words or less. Yes?
Warren, I'm curious about the interplay between your life as an entrepreneur and your life as an academic. Is the success in either one despite, or is that a synergistic thing?
Thanks, and nice T-shirt. he's wearing an AI2 intern T-shirt. I used to say that academia is kind of like playing bridge. It's cerebral, it can be intense, it's kind of slow, and entrepreneurship is like playing poker. It's high stakes, high adrenaline, and so on. You do use some of the same skills, and I would say that for me, it's actually been wonderful because I've never felt like, okay, I've got so many ideas, I'm going to do a startup every 15 minutes. Dan Weld and I did a startup which is called NetBot. Ed refers to it as NetBut. Every opportunity, I don't understand why. But then after that, Dan, he's so creative and energetic, he founded 3 more startups before I could finish my coffee. A bit of an exaggeration, but it's true. And it took me 7 more years until the next startup. So in the interim, I had the tremendous benefit of doing research and thinking about things. So for me, there's been a really nice interplay. And I love startups that are not just based on some wacky idea, but are based on some hardcore technology, on research and so on. So for example, Ali's startup, Exnor, which Apple bought, right, was based on research on doing computer vision at the edge, right? Doing computer vision with very low processing power. And there's a lot of research that went into that before they realized, hey, we could actually make a company out of this. This could really, really help. So for me, that's the way it's worked out. It's different for different people.
Oren, this is Jack. Thank you.